Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about our talks from 2021. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, much more. And we've talked about a lot of these different topics during 2021. And what we're going to do today is to go through many of those different presentations, pick out one or two concepts from each one, and basically just do a quick review. So with that, our first webinar this year was on reducing cost and escapes with predictive quality. And predictive quality is being able to tell when a defect is likely to occur before it happens. And that gives you a chance to stop the process, make whatever changes are required, and mitigate those problems before they actually happen. And so some of the key takeaways here are that it is a critical addition to companies' quality improvement tools. I-IoT systems can provide significant context to help the algorithm find the signal and the noise. And for these tools to be effective, they have to become part of the standard work for multiple organizations within the company so that people actually utilize those predictions to make changes in the process. I should say, as we go through here, if you have any questions as I go along, please enter them into the Q&A. And also keep in mind that at visualdecisions.com, for each and every single one of these slides here, there's an entire presentation with additional depth to the conversation. So with that, in our next presentation was I-IoT systems and distribution. And so some of the key use cases here you can see listed on the page. My key takeaway here is really some of the benefits. From a monetary perspective, you can prevent damage and spoilage. You can improve asset management within your distribution centers. You can have improved service levels and cheaper and faster delivery out to your customers. It's also important from a transparency perspective, being able to get real-time product tracking, inventory levels, visibility, supply chain visibility, and not least of all, perhaps most of all, from a human perspective, being able to help fight the talent shortage that exists within distribution industry through task automation, and also increasing the employee productivity so that you can keep up with the pace of the distribution demands. Next, we focused on a piece of software, I think for the only time this year, but it was a critical piece of middleware in Kepware. And Kepware is pretty standard within the industry for device connectivity. There are other solutions like it as well, but I believe that Kepware has a fairly dominant market share in terms of providing that middleware layer. And if you look at some of the critical features from a device connectivity point of view, data aggregation, communication optimization, security diagnostics, and so forth, as well as the advanced plugins, it gives you the capability to both connect to a really wide variety of different machines out on the shop floor, as well as other devices. But then also is able to present that information to a wide variety of different systems, whether it's a MES or Historian, ERP system, I-IoT, data going straight to the database, whatever it might be. You have that capability of now passing that information so that it simplifies your data architecture out on the shop floor. And rather than having to connect your MES system or your IoT system directly to all of the different devices, you can point those just to Kepware, and now you can utilize Kepware to handle the messy device communication. Our next presentation was on closing the gap between planned and actual results. So what we did was we kind of ran through the causes for mismatches between planned versus actuals, and that can either be creating infeasible plans in the first place because of incorrect runtimes or misunderstood starting conditions, missing data, et cetera, or variations in execution that can stereotypically come down to man, machine, method, material, measurement, and environment. And we talked about a lot of the different benefits of perfect alignment between those, such as if you had actual perfect alignment between your plans and schedules, you could have a very minimal amount of inventory. You would have 100% customer service levels, minimize your cash-to-cash cycle time, perfect quality, et cetera. But obviously, these are just goals, because no matter how much you try, you will still have variances in execution. But the more you can do to minimize those, the better off you're going to be. And so we went through and discussed how to address each one of these different sources of variation, as well as sources of bad data and so forth that create infeasible plans in the first place. And later on in the year, we'll get to a presentation where we talked about how to actually improve the planning and scheduling in the first place. Another interaction with other systems that we talked about from our shop floor data is how to use I-IoT and business intelligence together. And we kind of contrasted the two systems. There's actually a fair amount of overlap in terms of building visual controls out on the shop floor and reporting and things like that between the two systems, but they're fundamentally different in terms of the I-IoT systems are built to gather data in the first place. They're the point of connectivity out to the shop floor and how you actually gather that information in the first place. Whereas business intelligence systems are really built as a hub for analysis, where their source data is coming from other systems as opposed to the shop floor devices. Both are nearly infinitely flexible. Both can be used for visual controls and historical analysis and real-time analysis and so forth. Both can be integrated with AI and ML. And so what we did was we went through a lot of the different use cases and talked about how you utilize the different systems when you're going to choose one versus the other, and really how to create kind of an optimal blending between the two of how to utilize the IoT system for more real-time and the business intelligence solutions for more extended analysis, where you want to have a broader context of data flowing into that analysis. One of our big themes this year was human-centered manufacturing with our partner in Sandalwood Engineering and Ergonomics. And what this really centers on is human-centered design combined with lean philosophy, and then also pulling in how do you adapt the culture of the organization to really have that focus, first of all, on the humans within there, so that you're making everything as good as possible in terms of the work environment and so forth. But then also you're maximizing the efficiency and the effectiveness of your workers by putting them in that better work environment. And so this was a theme. We did several presentations with Sandalwood during the year around human-centered manufacturing, but I really just focused on this one slide to kind of cover all of those different presentations. I also took that and extended it with more of a detailed view of how do we augment operators within manufacturing, utilizing some of these Industry 4.0 solutions and so forth. And so how do we look at operator efficiency and how do we augment that with process and changes in technology? And some of the key use cases that I looked at during the presentation were augmented remote assistance, digital and augmented work instructions, connected work cell technologies, real-time production monitoring so that the operator doesn't have to have that responsibility, vision picking, autonomous maintenance support, standard work support, visual controls, Kaizen support, and so forth. And really looked at how the different technologies can help operators take more ownership of their own processes by supplying them and empowering them with some of this data and workflows. Next, we talked about maximizing mean time between failures. And this was the first in a series of world-class maintenance presentations that we did, where we looked at, kind of the critical metric of mean time between failure and how we can extend that mean time between failure as long as we possibly can. And if you look at what companies do today in terms of autonomous maintenance, preventive maintenance, condition-based, and then getting into predictive maintenance, we talked about how we can support each and every single one of those different activities, with data and with, well-structured workflows to help the people that are involved in that process have the information that they need in order to identify, what are the factors that are really driving the downtime, and being able to address that with various mitigation techniques and so forth. We also looked at some things that are kind of outside traditional maintenance, such as failure mode and effect analysis and Kaizen on root cause analysis, and how those can be supported with these Industry 4.0 solutions as well. Next in the series, we took a look at minimizing the mean time to repair. So mean time between failure looks at how long we go between failures. Mean time to repair looks at how long the machine stays down once it goes down. And when we look at the components of that time to repair, the operator has to become aware that there's an issue, that there's downtime. He has to be able to do that initial triage to decide whether it's something that he can hit a reset button or whatever and get the machine running again, or if he's going to need help. Then if he needs assistance, he has to make maintenance or engineering or both aware of the issue. Someone needs to get assigned to that problem. The worker has to become available. They have to travel out to the machine. Once maintenance arrives at the machine, they have to diagnose the root cause of the issue. They have to fix that, and then the problem is fixed. Or if they're not able to fix it on the first try, then they have to try again. And so the next item in the series that we looked at was maximizing the first time fix rate. And this is kind of the third critical metric within maintenance, is FTFR, or first time fix rate. And there are many reasons why first time fix rate is lower than it ideally should be. And we go through each one of those and we talk about how we can really optimize maintenance for each one of those different activities. And I should have said on the last slide that for each and every single one of these steps, we have the capability, whether it's through automation or whether it's through augmentation with machine learning and artificial intelligence, to help with the diagnosis, to help with identifying that there's an issue in the first place, getting that assigned, who should be working on it based on our initial automated triage of what happened, being able to add intelligence for who gets assigned and where they're located and so forth, and then being able to assist those workers with diagnosing and fixing the issue. And then we can address each one of these, or at least assist with each one of these to optimize our first time fix rate as well. So those three steps in the series really set up a presentation for later in the year, where we talk about maximizing our asset effectiveness. But it also leads directly into improving OEE with I-IoT. So in addition to all of the steps that we just talked about, minimizing our total downtime by maximizing the time between failures and then minimizing the time that the machines are down when they do go down, there are other factors that are involved with improving IoT. And perhaps the biggest is just taking action based on the data that we see. And this is where we heavily lean on an analogy of another IoT device, which is a Fitbit. And I talk about how I've been wearing a Fitbit for almost 9 years now, and I've gained 20 pounds during that time. And the reason is not that the Fitbit doesn't work. The Fitbit does exactly what it's supposed to do. These IoT systems that you can deploy out on the shop floor do exactly what they're supposed to do. But for me and the Fitbit, I haven't changed my behaviors. I still eat too much. I still don't exercise enough, and therefore I haven't lost the weight. And it's the same thing out on the shop floor. You actually have to take action. You have to change the behaviors. People fundamentally have to do something different tomorrow than they do today in order for these systems to provide the value that you're hoping for. And so at the core of this presentation, in addition to the things that we talked about before, is what are those behaviors that you have to change for your people to really utilize the information coming from these systems in order to improve your processes. And that kind of leads us into the next presentation, which is kind of the complete operations 4.0 program. And here we're looking at traditional lean manufacturing, traditional operational excellence programs, and how do we take those and kind of modernize those with all of these different solutions that fall underneath that Industry 4.0 umbrella. And so we look at the overall lean management system with things like standard work, both on the shop floor as well as standard work for leaders, visual controls. How do we make Gemba more effective? How do we put a management operating system in place that is real time and can tell us instantly whether we're winning or losing during that individual day, as well as a daily accountability process? What are the kind of checklists that we have to perform as people within the organization, and how does that vary by department? And then the lean toolkit itself in terms of Kaizen and root cause analysis and value stream mapping and failure modes and effect analysis and so forth are also part of what we can do to modernize how we actually approach operational excellence within the organization. So that kind of leads us into how do we actually create value with the Industry 4.0 solutions? When you're making an investment in whether it's IoT or augmented reality or some of the predictive machine learning capabilities and so forth, how do you actually get value from those? And in this presentation, we looked at, for instance, this data from the World Economic Forum in terms of how this actually leads to productivity increases with factory output or OEE or quality cost reduction, product cost reduction, speed for time to market, lot size reduction and so forth, agility, sustainability. And we talked about how we actually can create the links directly from what we're doing with the Industry 4.0, how that changes the processes that we have in place within manufacturing, and how that then leads to those actual dollar values in the end. Another key topic that we circled back to throughout the year is creating a data-driven culture in manufacturing. And what I'll focus on from this presentation was talking about who it is that needs to change within the organization. And so when we think about standard work, or we think about the culture within manufacturing, a lot of what we focus on is just the operator. And one of the things that we talk about in this presentation, among a lot of other topics, is the fact that the focus should be broader than just the people that are working on the shop floor. When you talk about creating that data-driven culture, you also have to think about the support teams, such as the manufacturing engineers, continuous improvement, quality, maintenance, facilities, IT. But fundamentally, management really has to embrace and lead the change. I talk about an experience at a cosmetics manufacturer down in Arkansas, where what we did was we created a leadership team that really focused on this data each and every single day. And each person from that leadership team was responsible for a different line or different area within the plant in looking at the data on a daily basis, on shift by shift basis, seeing what were the key issues and working with the teams in those areas to address them. And within a 12-week period, we were able to gain, I think it was 40% on OEE during that time frame. And so tremendous improvements in productivity because we had that commitment all the way from management all the way down through to the shop floor, including all of the different support staffs. And my presentation was frozen there. All right, so the next step, or the next presentation that we did, looked at the Internet of Things solutions versus MES solutions versus OEE solutions. And we discussed when you would want to utilize those different solutions, all of which can collect a lot of that information from the shop floor. So for instance, with MES systems, they have a very broad set of functionality. It's very well established. They have very well defined data models and integrations to a broad set of solutions. They're built to act as a system of record within your manufacturing environment, which is incredibly important for validated environments or places where you have to keep the genealogy, the history of what goes into which batches and so forth for legal reasons or other reasons. IoT systems are generally more modern architectures, not always, but generally they're nearly infinitely flexible, which is both an advantage and a disadvantage for them. They're built for connectivity. They're built as a system of improvement as opposed to a system of record. And they're built as a hub for the shop floor. So they don't necessarily look to own the data that they're collecting, which means that they can be kind of the center of a best-in-class solution. And you can use those as a hub to easily coexist and connect other systems together. OEE systems are much more limited in scope than the first two. They're really looking at just pulling information from kind of one machine at a time and analyzing the performance of that machine, looking for what are the reasons for downtime, what are the reasons for quality issues, and how do I go about improving those. Which, if that's the core of your focus, those OEE solutions can be very good, but you have to realize that they're going to act as a data island within your organization. And you really need to focus on how do I now look at my overall flow within my manufacturing environment and other topics that really don't get addressed just from the OEE solution. So during this presentation, we went through, kind of compared, contrasted, and looked at how to utilize these different solutions most effectively. Our next presentation was on predictive maintenance and going beyond actually just predictive maintenance within manufacturing and looking at machine learning applications in general. And we talked about more than 20 actual use cases for machine learning within manufacturing during this presentation. We had a focus on one though, where we're working with auto parts manufacturer that supplies to the OEMs, and how we connect to their systems for a grinding operation and utilize that to predict both from a quality perspective of when we're about to have a quality issue, but then also when do we need to replace the grinding wheels from a tooling perspective. So if we leave the tools on too long, we're going to end up with bad parts. If we take them off too quickly, our tooling budget is going to be too high. And so how do we utilize, in this presentation, we talked about how we utilize these predictive capabilities to look at both optimizing quality as well as our amount of spend on the tooling. The next presentation that we did was a series on operational excellence plus Industry 4.0. and the impacts on quality, cost, and delivery. And so we started off by looking at what are the key sources of variation within the manufacturing process, and what are the things that most impact quality. And then we looked at how we can utilize solutions such as augmented reality to help with the people in the process and the methods that we're using for manufacturing to ensure that people adhere to the standard work and understand what the standard work is, utilizing IoT and machine learning to look at the machine data itself and so forth, and also provide feedback loops with the operators in the process. And then also incorporating that entire view of all the different sources of variation and how we can eliminate or mitigate those different sources. For improved costs, what we looked at was how we actually tie what we're doing within this process directly to the income statement and P&L. So, what are the different things that we can do from a process improvement point of view to increase revenue? And, an obvious one is if you're in the situation where if you can make more, you could sell more, then if we can improve your OEE and your overall output of the factory, then we have the ability to increase sales based on doing so. But there are other ways to look at increased sales as well, such as if you produce higher quality parts, you can either charge more for those parts, or you can get additional contracts because you have a better reputation within the marketplace. If I reduce my lead time out to my customers, very often that's going to be a competitive advantage in the marketplace, and I can win additional business that way. And so there are a number of different impacts that we can have that will increase sales. And likewise, for many different categories within our expenses, we can have many different types of impact on each and every single one of those different expense lines. And then from a balance sheet perspective, we can certainly impact all three phases of inventory, as well as our plant, property, and equipment spending. And then on the delivery side, we kind of take a look at a lot of the same things that we talk about with OEE, but how do we improve basically our schedule adherence by reducing that variability within our manufacturing process? And whether that's looking at the machine breakdowns and maintenance that we've discussed previously, or looking at things like setups and changeovers, and how do we improve our SMED, or single minute exchange of dies process, or just any type of changeover analysis that we do in order to minimize the amount of time that we spend in setups, as well as minimize the variability that we have in our setup time. And then process failures, manpower issues, material issues, all of which can be addressed with Industry 4.0. The next presentation was maximizing equipment availability with Industry 4.0. And this had a lot of overlap with some of those previous presentations. But one of the things that we have talked about several times during the year that I'll highlight for this presentation was working with FMEA, failure mode and effect analysis. And this is a process that's typically done in a conference room where you gather a cross-functional team, they go through, they brainstorm essentially what are all of the different potential failure modes for a given process or a product, and then looking at what are the potential causes or mechanisms of failure that would drive that failure mode. And then for each one of those different causes, looking at what is the potential severity, what's the probability of occurrence, and what's the probability of detection. And if you think through what we're doing with either an OEE system or IoT or MES, as we collect information from the shop floor, we're actually collecting the downtime or quality issues from the process, whether that's looking at the fault codes coming from the machine, or whether that's having the operators press the buttons to enter what was the actual failure that we saw. And the vast majority of the time, even if an FMEA has been done prior to the implementation of those systems, they're disconnected from that FMEA analysis. And so what we talk about during this presentation is how to connect your FMEA analysis with the data that you're collecting from the shop floor so that you can automatically categorize, each one of those different failure modes for what is the severity, how often is this happening and how long does it stay down for? What is the total amount of time that we're losing, as well as any safety impacts and so forth. And then from a probability of occurrence, certainly, we can build out that Pareto and so forth. And also probability of detection here leads us into how we actually collect the data. And so when we look at each process and we're thinking through, what is the data that we want to collect from the process? If we have an FMEA in place, we should look at that FMEA to actually guide us on what is the data that we want to collect in order to identify or automatically detect what is the particular failure mode that we're seeing and what is the cause that we're identifying based on the data that we're collecting. And so there's a very symbiotic relationship between that FMEA process and the data collection process that we do on the shop floor to improve our OEE. Likewise, with another lean tool, we took a deep dive into improving Kaizen with Industry 4.0. And we looked at the 6 different stages of a Kaizen process and how data can really help us with each and every single one of those different steps. And if we have broad-based data collection in place before we start the Kaizen process, we're much more easily to identify what are the Kaizens we want to run, how to analyze that current process, brainstorm different alternative solutions, test or even simulate those different solutions in advance of implementing them on the shop floor, being able to measure and analyze the results naturally, and then how do we standardize the solution? How do we actually update the standard work and make everybody aware of what that new standard work actually is? So technology can really support us for each and every single one of those. We took another look at operator impacts and interfaces and standard work. And I talked about some of this earlier, but from the use cases that we looked at, looking at training, digital work instructions, standard work support, autonomous maintenance, visual controls, quality monitoring, setups and changeover optimization, automation of routine tasks and performance monitoring, decision support, safety, all of those different things we can look at for how do we support and empower the operators in the process. Instead of looking at the right side picture there, we dove in a little bit into the history of Taylorism and being able to automate or standardize those different tasks and break it down to its lowest step, and then basically treat humans as automatons to perform those individual steps. And instead of going down that same route, we really look at how to humanize the process and empower the people within that process, and again focus on human-centered manufacturing and so forth. Then we looked at improving planning and scheduling with Industry 4.0. And I talked about some of the different things earlier in terms of how to improve the original schedule generation with better data, and understanding the current conditions on the shop floor and what machines are set up for what process and so forth. But what we talked about here is also that things don't always go according to plan. And the real key to having a robust planning and execution environment is the ability to quickly detect deviations from the plan and make quick adjustments. And so there was a strong focus within this presentation, not on planning in the first place, but being able to replan rapidly with that information that we're collecting from the shop floor. Next, we talked about bottom line impacts of Industry 4.0, and we went through in detail the visual decisions model for creating that benefits case for Industry 4.0 in the first place. And we go through a top-down analysis, starting with, what are the overall goals of the business, whether it's, increasing output, or whether it's reducing cost, or whatever it might be, improving quality. And we go through and analyze, what are the key impediments to that current, to improving the current performance. And then we try to take each one of those different impediments and drive that down, not necessarily all the way to a root cause level, but to something that is actionable. And then we can identify what are the process changes that we need to put in place to address those root causes, and what are the technology enablers that will allow us to support that new process. And that will allow us to estimate what is the benefit or outcome that we can actually get from implementing Industry 4.0. Next, we took a deep dive into how to reduce OEE losses by 50%. And we went through some case studies of, for instance, that cosmetics company and so forth that we looked at earlier. And for each one of the different major loss categories within OEE, we looked at some customer examples of how we were able to address major breakdowns or setups and adjustments, short stops, reduced speed, rejects, and so forth. And how we're able to mitigate each and every single one of those different issues, utilizing the combination of smart manufacturing and lean manufacturing. Our next presentation was on getting the most from your Industry 4.0 investment. And this leaned heavily on some of the things that we've talked about before, in terms of putting the proper culture in place, having that data-driven culture, looking at the combination of your operational excellence process with some of these smart technologies and so forth. But one of the things that we really hit on here is that if you want to cool off in the summertime, you can't just dip your toe in the water. At some point, you have to jump in the pool. And it's the same thing with these different solutions. For instance, we had a customer that implemented the technology just on one machine in order to try it out. And the data was collected just fine. It went into the database. It supported good analysis and so forth. But because it was only on one machine, the people that were involved, the supervisors were responsible for an entire value stream. The individual operators even had more than the one machine that they were working on. They rotated throughout the day and so forth. Maintenance, had the entire plant. Engineering was supporting the entire plant and so forth. And so even though there was this really rich data available from that one machine, there was nobody that really had that as part of their daily workflow to look at that information and use it to improve the process. And so the technology proof of concept worked fine, but management was hesitating to move forward because they weren't getting the process improvements that they were hoping for from that investment. And I had to really work with them to understand why it was that they weren't getting the improvement. And it's not magic. Again, just wearing a Fitbit doesn't make you thinner. You actually have to do something with that information. And so, eventually you can't just, implement this in one area and hope that that makes it better. You have to make it part of people's lives, and you have to really embed it into the daily process. And to do that, you have to make a broad-based implementation. We also talked about real-time variable cost management. And the idea here is that we're able to not only get uptime and downtime information, how many units fail, quality inspections and so forth, but we're actually able to dollarize all of that in real time. And so we talked a little bit about lean accounting and being able to really focus on the variable costs within the process as opposed to the overhead allocation and so forth. And from those variable costs, be able to tell, am I winning or am I losing today? And, talked about background with a couple of different COOs that I've worked with where, their real focus was, how do I give my people the information at, a real basic level of, am I winning or am I losing? And what do I need to do in order to adjust during the day? And if we can do that in real time, then that gives their talented people out on the shop floor the best opportunity that they have in order to win each and every single day. Next, we circled back again to this idea of combining smart and lean. Smart manufacturing with lean manufacturing, and how do we combine Industry 4.0 with operational excellence techniques? And there's a lot of the points have been covered already here today, but one of the things that I wanted to focus on was one of the objections that I get to modifying these lean processes and so forth is that the reason that people still use whiteboards and the reason people still use printed reports and hand calculated numbers and so forth is being able to maintain those fingerprints in the process. That the belief is there that the ownership will be much higher if all of that is done manually, as opposed to having automated systems tracking downtime and things like that. And I went through kind of a detailed answer during this presentation to that objection that I don't have time for today. But in summary, if you really look at the standard work of the organization and you embed all of this into the standard work so that people are utilizing the information to improve the process, just writing numbers on a board doesn't really create ownership. It's utilizing that information to improve the process and really having people take ownership of that improvement that is going to drive that real, true ownership over the long term. And so how do you get people to invest really in the change and the possibilities and so forth, as opposed to just, mechanically, recording information on a whiteboard? Another aspect of lean manufacturing that is very typically done is value stream mapping. And this is another place where you typically lock people into a conference room for a number of days, and you use sticky notes, all over the wall and so forth. And you go out to the process and you manually collect, how long do things spend in process? How long do they spend between processes? There's typically a lot of guesswork. There's a lot of kind of, sticking your finger in the air and thinking, okay, well, it's about this much time that it spends between processes typically. One of the things that we talk about is that if you are utilizing an MES system, if you're utilizing I-IoT across the entire process and so forth, and you're tracking the work orders, across that whole process, and you understand how the different work orders tie together from a bill of materials perspective, at least within discrete manufacturing, then you have the ability to automatically do the bulk of the value stream mapping. And you can look at how much time things spend in process, how much time they spend in between processes, but you also have the ability to look at not just that average amount of time, but the entire distribution. And what is the minimum, what's the maximum, what is the typical amount of time and so forth, how much spread do I have, what's the standard deviation there? And now as I'm looking at that, I can use it as a real-time tool going forward to be able to see not just the standard flow through the system, but what are all the different paths that a particular product might take through manufacturing. I can see the variances as things go through rework cycles or anything else, and I can see if I'm spending more than a typical amount of time either in a process or between processes, I can highlight that and I can bring it to people's attention so that things kind of don't get lost out there. And a lot of this capability is already out there today. The data is already out there. It's just not being utilized in this format, and people are still manually performing this. And so there are a ton of advantages to automatically doing value stream mapping, which I cover in that presentation. But this is kind of a highlight of those different advantages. My next presentation was going through agility, and this is the one presentation I'm actually going to use 2 slides for. So when I look at agility and I think through agility versus efficiency, I have a good friend that works for Aviva that I was having this conversation with that kind of led me down this path. And there's really traditionally a trade-off between agility and efficiency, where you have shock absorbers for the business, such as inventory, whether that's raw material, so that I can continue running when something doesn't show up because of supply chain issues, or whether it's excess capacity so that if Bob doesn't show up for work today, I can still run the process because I have enough people. Financial with excess capital so that I can put things in place when I need to and so forth. Time, I'm quoting longer lead time than I need to so that I can handle the variations within manufacturing and so forth. And so for a lot of years now, the focus of business has been to run as efficient as possible. How do I minimize those shock absorbers that I have in place so that I run as lean as possible with as little inventory and as little excess capacity as I possibly can, minimize my workforce and so forth, shrink that quoted lead time out to customers. And with the world as it has been the last couple of years, that's actually led to a lot of problems in manufacturing, where because of the supply chain disruptions, because of the human disruptions, whether it's people out sick or a lot of the mass retirements that we've had, or people changing jobs, there's been a lot of different issues that we've had that have really put manufacturing in a bind because the focus has been so much on efficiency that those shock absorbers haven't really been present. And so how do you create the agility within manufacturing while still maintaining efficiency? And if that's a trade-off, how do you shift that entire trade-off curve between the two so that you can increase both agility and efficiency at the same time? And we went through a number of different things, such as setup reductions that are going to help you with both efficiency and agility, so that I can change over more rapidly from one product to a different product, when I have disruptions in the supply chain, and a number of different topics like that. And then what we really got to was, how do I create both an agile and efficient organization across my operations and supply chain, my leadership and culture, organization structure and adaptability of that, and then product innovation and development as well. And all the while having kind of a customer-centric approach, so that as I have rapid changes in my demand profile, as we've seen in the past couple of years, I can respond to those and understand what are the drivers behind those as well. Using I-IoT and BI together to drive performance improvements. With that same friend from Aviva, we looked at situational problem solving, systemic problem solving, being able to utilize the right solutions at the right time, and then also being able to, on kind of the other axis here, go from monitoring and detecting the problem all the way through to taking action upon it. And during this presentation, I kind of used this framework to talk through when you would utilize the IoT solution versus the BI solution. And basically what it comes down to is the items that are in blue, you would utilize the IoT solution because it's more of a real-time or near real-time situation. And being able to use those real-time capabilities of that system and the visual controls and everything else that you can put in place with them really help with these different activities. Whereas the systemic problem solving and offline, I can create workflows within a business intelligence solution that help me really analyze the problem, as well as putting the machine learning and artificial intelligence in place to determine what are the different actions that I should take. And so we went through this analysis and really dove down pretty deep into how to use those together to drive those performance improvements. Here earlier in December, we talked about how to get started with Industry 4.0. And we went through and looked at, again, that model for how you create value. If you remember the two triangles, one pointed down, one pointed up, for top down and then bottom up analysis. That is a big key in order to be able to determine, how do I really get started? How am I going to get value? What aspects of Industry 4.0 are important to implementation for my operation? And when we look at that top-down analysis, we kind of go from, what are those opportunities? What are some of the financial inputs that are, part of those? Looking at the causal factors that, really drive the performance, in those different areas. And then how do we tie that or map that into, what are the different enablers and process changes that we can put in place? And so, going through that analysis was the core of this particular presentation. Kind of our last presentation that we have here that we're going to go through is root cause analysis. And, we looked at really the revolution that you can have in place now for doing root cause analysis with the level of data that we have today versus, going through and doing a 5 analysis or, a 5W and 1H analysis, that have been done in the past, where you're really just kind of guesstimating, what those different causes are. With the data that we can collect today from whichever source system, you have the ability to do a lot of automation with the workflows for the different root cause analysis methods. So if you're looking at who, what, when, where, why, how, if you're contextualizing the data coming from the shop floor in the first place with who's running the process, what time of day it was, et cetera, now you have that information that you can kind of slice and dice your data with to see, does it matter for my downtime who's running the process? Does it matter whether it's a Monday or a Wednesday or a Friday? Do I have more downtime immediately after lunch and so forth? Similarly with the 5Y analysis, I can start to go through that causal chain and look for what are the real sources of the issues and how does that kind of pile up to that top level impact. And then fishbone or Ishikawa diagram is really just another representation of a 5Y analysis. Graphical evaluation is something that we've done quite a bit at Visual Decisions, hence the name. And then going through FMEAs and statistical analysis of factors such as with ANOVA's analysis of variance, design of experiments, et cetera, and being able to have the data that informs all of these different root cause analysis methods, and then the workflows that you can put in place to support people running through that analysis, and then automation for being able to automatically run through those and detect what the true problem is. And so that's kind of the last presentation. Some takeaways for kind of the entire year in terms of utilizing some of these Industry 4.0 solutions in manufacturing. Data is absolutely critical to identifying the improvement opportunities, analyzing the cost factors, generating solutions, and more. But you want to avoid implementing technology monuments. In lean manufacturing, a monument is something that can't be changed and that you kind of have to build around. And so as you choose solutions, you should choose solutions that are easily adapted and improved as your manufacturing situation changes over time. You're continuously making improvements to machines, putting new machines in place, changing workflows, optimizing processes and so forth, and your solution should easily adapt alongside that. So in terms of implementing these, there's a strong overlap with Agile concepts of a minimal viable product and incremental solution improvements. And our recommendation is to utilize solution platforms like I-IoT and AR combined with Agile methods to continuously improve the process and the supporting technology together. And then just a few closing thoughts. One of the keys here is to be able to tell, as my COO friends have said, am I winning or am I losing today? And how do I get my people the base information that will tell them, am I winning or am I losing? And what does that really mean within the organization? In addition to increasing efficiencies, which we've had drilled into us for many years now, we also have to think about agility and how we increase that agility over time. And then part of how we do that is the real-time ability to sense and respond, and that and respond is absolutely critical. And then over time, in addition to that real-time focus, how do we identify and mitigate the endemic or long-term issues that we have within the operations? So with that, thank you. It's been a great 2021. I look forward to continuing this series into next year and having many more discussions. If you have any questions, please reach out to me at tim@visualdecisions.com or 630-957-8096. Thank you and have a great new year. Bye-bye.